Blower assembly is designed to push a certain amount of air a certain distance in a certain time, using a certain amount of power. Alright, just like our little guy here, he can push a certain number of boxes a certain distance in a certain time. Alright, so at its peak performance it can do this no problem. It's not going to strain a bit, not an issue. Alright, let's look at the next one. Same guy, still push the same number of boxes, but now we've added 2 boxes. Now anything over 5, he can only push 5 boxes. Anything over 5 becomes a resistance. So as he's pushing these 2 boxes, or these 5 boxes, to the finish line, I've got 2 boxes that's pulling him back this way. This is resistance. It's going to make it a little bit harder for him to get to the finish line. Alright, take it one more step. Now we've got the same guy he still can push the same number of boxes, but now he's got 5 boxes pulling him back. He's not a very happy camper right now. He's going to do it, but he's going to give it his all. He's going to really struggle. So what we need to how we got to look at this is, a blower motor is designed really to run at about 0.5 CFM. And it can get its job done pretty good at 0.5 CFM. That's this guy here. We got 5 boxes, 0.5 CFM. Now when we start adding restrictions to the system, that's here. We're adding restrictions. I've still got to move a certain amount of air, but now I've got this restriction that's holding me back. And now we're going to look at this. If you measure your static pressure, and it's a 0.7, I'm designed to push 5. I'm going to push 5, but I'm going to have 2 holding me back. So it's going to make it harder for me to get my job done. Now if you've got the crazy static pressure of 1 inch water column, that's 10, 1.0, we're still going to push our half of that, 5, but then we've got 5 that's pulling us too. He's going to do it, but he's going to struggle really hard. Now we're going to take this one step further. Now we're going to have a little relay race here. I've got this guy that's really fit, in shape. He's going to push these 5 boxes to the halfway point, and then from there, this guy is going to take off, push his 5 boxes to the finish line. Now both guys is trained for this. It's not going to be much effort for them. They can do this no problem. But now the competition is getting a little scared, so we're going to cheat a little bit. They're going to have 2 kids come over here and try to stop him from pushing the box to here. So I've still got to get here in a certain time. If these guys are slowing this guy down to get to this finish line, this guy can't possibly finish here in time. So basically this guy is going to finish no problem. This guy is going to get to the midsection, but he's going to have to work a lot harder. So it's going to kind of ruin the time for the whole team. Alright, so let's compare this to our furnace system. This is my return. Midway point is my furnace and my coil. Then my supply, and ultimately be my registers out here at the finish line. So the starting point would be my return air grills, and you've got your ductwork, that's the road, and you got your furnace and coil, that's where you transfer it over to the supply. It finishes it. Now if I didn't have these 2 guys here restricting my airflow, just like the racers doing the relay, my air is going to go into my return air grill. It's going to go through the furnace and come out to the supply, no problem. Alright, now just as soon as I start adding restrictions to my return, ultimately it's going to affect my end result. air is going to go slower through the system. It's just not going to perform as well as it would as if I didn't have the restrictions. So what we want, now ideally you would like to try to get like we'll just say a 0.1 inch water column on the return. You have a filter here. You want a 0.1 inch on it, and you have a coil. We'll just say 0.2 inch on your coil. Then your supply, we want another 0.1 inch. If you add all these together, 2, 3, 4, 5, that gives me my 0.5 inches water column. Now if we start adding resistance, just like we did in our race up here, if I add 0.1 inch in the return air duct, whether it be the registers or the takeoffs or an extra elbow, whatever the case may be, and we use a thicker filter, we add another 0.1 inch here, we're going to add that to the bottom line. So now where we had 2, 3, 4, 5, now we're going to have to add the other 2, 6, 7. So now we're up to 0.7 inches water column. So I guess the ultimate question is what exactly is the resistance? Well, basically it's pretty easy. Besides the furnace, it's everything. The coil, ductwork, let's say coil, ductwork, supply pipes, registers, takeoffs. I mean everything that's hooked to this furnace or to this ductwork ultimately will be a resistance. Same thing when you return. Takeoffs, grills, whatever the case may be, everything that hooks up to this ductwork is going to be a resistance, and that is basically static pressure. Your filter is going to be a static pressure. You're going to have a resistance going through that filter. So that's going to be measured by static pressure. Your coil, I have to blow air through this coil. There's going to be resistance here. That's going to be measured in static pressure. So when you're designing the system, you want to read the product data of all the takeoffs, elbows, everything, your supply ductwork, just everything, and you want to try to achieve a certain total static pressure.